So students, now we are going to discuss the network applications. And the network application, it's categorized. So 6 categories that contains the majority of the SDN application. So the first one is in front of you. It is data center networking. We will discuss about this category. Then mobility and wireless, information centric networking, traffic engineering, measurement and monitoring, and at last security and dependability. So let's discuss briefly the 3 categories. So student, the first one is traffic engineering. Okay. Actually, student, the traffic engineering, there should be some strategy. We should see that there should be some strategy or plan for establishing routing and forwarding of data. So actually traffic engineering is responsible to make some strategy or plan for establishing routing and forwarding of data, but it should be based on quality of service requirement, please. It must be based on the quality of service requirement. So is the method of dynamically analyzing, regulating, and predicting the behavior of data flowing in the network. With the SDN, the task of traffic engineering should be considerably simplified. It should be considerably easy, not complex, as compared with the non-SDN network. The last thing they mentioned that SDN offer a uniform global view of heterogeneous equipment, like dissimilar equipment. You can say with respect to the vendors or with respect to the architecture. Okay. So now let's see the functions of traffic engineering that is implemented on the SDN applications. The first one, students, is mentioned like on-demand VPN network. Okay, it can be. This is the one of the most important function. So VPN, we know that VPN it gives you online privacy by creating a private network from public internet connection. Okay? Private connection from public internet connections. Okay? VPN it masks your IP address, so your online actions that are virtually untraceable. No one knows. So on-demand VPN network established. Then the second thing here they mention, the second function is load balancing. So in the purpose of load balancing, the main purpose, as we know that, is to prevent any single device from getting overloaded, please. From getting overloaded. Any device. And possibly breaking down. Okay, we have to avoid. So in other words, load balancing, it improves service availability and help prevent the downtimes of your network. One of the, again, very important function of traffic engineering. Then student, we have energy aware routing. Energy aware routing, actually it relates to low energy consumption. Low energy consumption. So this actually this important function it utilizes the both energy available in the node and quality of the link to identify the best possible route to the destination. So next is the QoS enforcement, and QoS enforcement is based on differential services architecture. Okay, which we already discussed in QoS in other courses. Okay, it is based on the differential services architecture that allow assigning different transmission characteristic to different class of services. Okay. Then students, we should realize that traffic engineering with minimal overhead. The overhead should be minimum. And then fast recovery through failover. We know that failover is a feature that improves the failover time for the storage stack configured in the clustered environment. Okay? Clustered environment, basically in the failover work in the clustered environment. These changes provide significant reduction in the failover time taken by the storage resources during the service group failures. So these are the few function, students, and very important function of traffic engineering. The next one, student, it's the measurement and monitoring, very important category of SDN application. This measurement and monitoring is further, it is divided into two categories. The first one, it's written here that new functionality for other network services. So these applications provide new functionality of other networking services. What other networking services? They're talking about like broadband home connections. Okay, here it's given the example broadband home connections and home and measurement of any home network traffic, any home network traffic. And the second category is add value to open flow based SDNs. Okay? For example, student, this thing it relates to open flow devices like open flow switches. It also involves sampling and estimation technique to reduce the burden of control plane in collection with the data plane. So in the collection with the data plane. So the next category is the security, very important category. And in it, students, they say that the security application have two goals. The first goal addresses security concerns related to the use of SDN. So student, here is the SDN, our SDN architecture. Okay? Our application plane, control plane, data plane. Here's our SDN architecture. So all the security concern, first goal, related to the use of the SDN, it addresses to it. The first thing they mentioned here. But what is the second thing? Use of the functionality of this SDN, okay, to improve the network security of what? Your whole network, to improve the network security. Okay. We will use the functionality of SDN to improve our network. This is our network, let's assume. So we have to improve the network security. So in detail, we are going to discuss in the next lecture about the security of the SDN. So now the next important application category is data center networking. So in data center networking, we discussed about the cloud computing data centers. Well, basically, what's a data center? Data centers are simply we can say it's a centralized location where computing and networking equipment is concentrated for the purpose of collecting, storing, processing, and distributing. Okay, allowing access to the large amount of data. You see, it's data center. And the features of data centers, the first one they mentioned, very important, agility in provisioning network resources. So in the word agility, we say it's basically it's responsiveness. How responsive is your network? Responsiveness. Okay? So in provisioning, in setting up your network resources, very important, agility in provisioning the network resources. The first feature, okay, of data center networking. The second one they mentioned high bandwidth and low latency. Okay? Yeah, high bandwidth and consuming low latency. The third one, QoS based on the application requirement. QoS is based on the application requirements. intelligent resource utilization to reduce energy consumption and improve overall efficiency. At last, the last feature, high level of resilience. What is resilience? It's explained capability to recover quickly from failover. So students, the next category of the application is mobility and wireless. Actually, in recent years, uh, a number of SDN based application for wireless network provider has been designed. So many. So let's see the first one, the first example they mentioned, like seamless mobility through efficient handovers. So let's get the concept of first of all what is handover. Okay. For that, just hold on. Uh, so basically, when we talk about handover, yes, handover. If this is one access point, and here is the cell of one access point, and here is the other access point. In Wi-Fi network, we have hierarchical Wi-Fi, and so in hierarchical we have access point. Access points are connected to one switch. A switch is connected to a router. So student, handover. In wireless network, the term handover or some, you can see some word like handoff. In the books, these words are used. It refers to the process of transferring an ongoing call or data session from one channel connected to an other channel of an access point. Okay? One channel to another channel of an access point. So ongoing call being transferred from, you see, one to another. So let's see in our slides. Here's it. Seamless mobility through efficient handovers. Secondly, creation of an on-demand virtual access point. So virtual access point, we can say it's a secondary Wi-Fi hotspot that is created within a physical access point, one physical access point. So one or more virtual access points, like a logical access point, can be created for different purpose. For example, a virtual access point with one SSD could allow guest access to the internet, while another virtual access point with different SSD could be set up for employees only. Okay, one for the guest and one for the employees. So the third one is the load balancing. Just hold on. Yeah, the third one is the load balancing, which we already discussed. Load balancing. Then dynamic spectrum usage. When dynamic spectrum usage. So dynamic spectrum, it referred to a dynamic spectrum access. That is a set of techniques based on a theoretical concept in networking information theory that is being researched now and developed to improve the performance of a communication network as a whole, as a one. So simplified administration also, it's easy administration. So easy management of heterogeneous network technologies, different dissimilar network technologies, and then interoperability between the different networks. So interoperability is actually, we can say, is the continuous ability to send and receive data among the interconnected network, providing the quality level expected by the end of the user without any negative impact to the sending or receiving network. Okay? So continuous ability to send and receive data among interconnected networks. Then students shared wireless infrastructure and management of QoS and access control policy. So these are some important points regarding mobility and access of the mobility and the wireless access. So student, the last category of application in application plane is information centric networking. So student, before going ahead with information centric networking, let's have one more thing. Uh, we have student one thing called traditional network or traditional host centric networking. In traditional host centric networking, the traditional network, it consists of a host, we know that is named by the IP address and which is based on the location in the network. Therefore, since the name is bound to the address and the address is based on the location, okay, so we need to contact get a specific information from a web server, specific web server. That web server has a specific location. So, but now we have information centric networking. It means information is retrieved and named regardless with the detail and location of the host. No detail and no location, okay, of the host, but we will get the information. This is the essence of information centric networking. So ICN, also known as content centric networking, because we based on the content, has received a significant attention in recent years, mainly driven by the fact that distributing and manipulating information has become the major function of internet today. So in ICN, it is aimed for efficient information retrieval. We are concerned with the information. We are not concerned that from where the information is obtained. What is the location of that host? We are not concerned with that. So ICN is aimed for efficient information retrieval by directly naming and operating on informational objects only. Unlike the traditional host-centric networking paradigm, where information is obtained by contacting specific named host, as I already discussed with you in the beginning, that in traditional host-centric networking, we need to specify the host, whether it's a web server or whatever it is. In ICN, instead of specifying a source, destination, host pair for communication, a piece of information itself is named. So information is named, not the host on which that information is available. Okay? So this is the ICN. So I repeat, in ICN, information is retrieved and named regardless with the detail or location of the host. Diagrammatically, you can see here. Okay, here is the user. He need to connect with the server. Let's assume it's a specific web server, and he to obtain information about this object from the server. So he will get and get the information back over here, okay? Because a specific host is available on the internet, and from that host he will get the information. Okay? That is called, we call the host-centric network. When we talk about ICN, information centric network, we are concerned with the information, okay, not about the specific host. So ICN student, it decouples, okay, information for its resources. Need to get only the information. So here is the client one searching for the information and get that information from any place. Okay, let's assume from here it get the information, and now information is returned back, okay, to the client one. Similarly, client two, it needs to get the information, okay, any information. So routing of information requires the seeks to find the best source for the information based on the location independent name. Okay, location is not visible in information centric networking. So students, the information centric networking distinction exists between location and identity. It decouples information for its resources. That already has been said. It decouples, okay, separate information for its sources. So the essence of this approach of ICN is that information sources can place and information users can find information anywhere in the network, okay, or in the big internet, you say, on the internet, on the big network, because the information is named, addressed, and matched independently of its location. Okay? So information is named, addressed, and matched independently. The word independently of its location. So in ICN, after a request is sent, the network is responsible for locating the best source, okay, about that desired information, the best source. Routing of information requests the seeks, it means to find the best source for the information based on the location independent plan. So the location of the information is hidden, it's not visible to the user. So when we deploy SDN, when we deploy ICN on traditional network, it is challenging because existing routing equipment would need to be updated or replaced with ISN enabled routing devices. For ICN, we need ICN enabled devices, students. One important point. So further, ICN shift the delivery of model from host to user to content to user. So user is not interested with the host now. User is interested with the information, with the content. So what is the beauty of ICN? It shifts, okay, from host to user to content to user. So content is given to the user, not the location of the, or where is the host, where is the information is hosted, okay. So that will not be given to the user. Instead, our content, the information itself, is given to the user. So this creates a need for a clear separation between the task of information demand and supply and task for forwarding. SDN has the potential to provide necessary technologies for deploying ICN because it provides programmability. Okay, it needs a programming of the forwarding element as separation of control and data flow. And some technologies like they have some special equipments or routing devices that are ICN enabled. That is ICN enabled. So students, we have finished the 6 categories that contains the majority of SDN applications. So now the last part we will discuss about the network services abstraction layer and frenetic.